Hey guys, welcome back to the channel. This is part 2 of the antenna tuner video. If you missed the first part, click on the card in the corner right now to see that first.
In this video we're gonna cover 4 topics. First topics, difference between commercial antenna tuners like MFJ or some other tuners and this tuner. How to make hardware and software for this controller. How to test this tuner using antenna analyzer and the radio. And on the end, what to do with the results. So what is different between this tuner and commercial antenna tuners that you can buy? This tuner actually should not be called antenna tuner. This tuner should be called antenna resonant tuner, because this tuner actually tuned the antenna to resonant frequency for the optimum gain in transmission and receiving. To comparison, the antenna tuners that you can buy actually just filter out reflective waves coming back from antenna, and it's only used actually to protect your radio, but doesn't improve performance of your antenna. So how to make this controller box for the antenna tuner? This box contains LCD display, few switches, and one potentiometer. Originally, for adjusting the coil, I had a switch that you can push up or down, but the spring is pretty hard inside, so it's difficult to use it because this box is very light, and pushing the switch actually pushing the controller box. So I replaced this switch with 2 push button switches, one to move the motor in one direction, one to move motor in another direction. Inside this box there are 3 PC boards. One PC board is actually LCD display. This is serial LCD display that use the serial communication like RS-232. This is not I2C LCD display. The reason why I didn't use I2C display is because you cannot find good information how to program it, because it's made for Arduino and Raspberry Pi, and you just download the libraries where all these settings is for those display, and you're just using it. Because I'm using controller with PIC chip, it was very difficult to program. I start with that, but I actually removed that display, and then I use a serial LCD display. They used to be available pretty much everywhere. Today it's a little bit more difficult to find them, but I found this one on Amazon. It has a backpack that is plug-in. So basically you can use this backpack with this LCD or any other character LCD display. Also, main controller board. This is my first one with a different PIC chip. You can see I make some jumper wires for a different connection, and I was planning to use that because on this board I also put the H-bridge. This is my generic controller board that I can use for different things. What I found out that actually this chip doesn't have protection from the short circuit, so in case your linear actuator gets stuck for some reason and start drawing more current, it actually burned the chip. So while I was testing it, I replaced this chip several times. So this board is all surface mount components. It's not completely populated because some other functions I didn't need. So I just populate the board with the components that are needed. Components are very, very small, and it's very difficult to solder. This board, you need to use a microscope. So lots of people don't have experience with making those boards. So what I did, I made another board that is not one that is in here, but one that it will be available to download with through hole components, that using all these regular resistors, capacitors, and chips that actually just go through the holes, and it's all soldered on backside, so it's very easy to assemble the board by anybody who has a little bit of skill with a soldering iron. For this purpose, for this controller, I'm not using this H-bridge. I actually bought a H-bridge small PC board from Amazon, and it cost about $5. And it actually has two H-bridge outputs, and this is power that you put voltage for the motors, and these pins here are control for the motor. Okay, so you can control it just to turn it off and on, or you can put pulse width modulation on one of the pins and control the speed of the motor. And it requires only two I/O lines to control one of the motors. To comparison, this chip requires 4 I/O lines, because it has two I/O lines for the direction, and it has a separate I/O lines for the standby, and a separate I/O line for the pulse width modulation. This one has only 2 pins that use, so using one pin low, one high, start motor in one direction, also reversing those 2 pins, working motor in the other direction. If you put a pulse width modulation on one of the pins, you can control the speed. If you connect both pins to the ground, it's activate the brake, so you can stop the motor. And when you put both lines high, it disconnects power from the motor. Okay, so it has one ground pin and then 2 pins for each H-bridge chip. So basically what you can do, you have input A1 and input A2. So if you connect this input A1, with some jumper wire to B1 and A2 to B2, then both of those output will work. So in case you have something that one chip burn out, you just unplug your motor from this connector and plug it into another connector and continue working. So this is the cable that came with the board. You got 3 of those cables, and you just plug it in a board. This board, it's here. It's running on 3.5 amps, and voltage you can put on a power for this cable. It's on this board. It's from 7.5 volts to 40 volts. So it can be used for different applications. On the back side, there is a 5-pin connector where you connect to your coils. 2 pins are for the driving the motor, and 2 pins are for the feedback potentiometer coming back for the position of the slider on your coil. So I decided to go with 5 wires just to simplify things, and the cable is available pretty much everywhere. And this is cable for the LCD strips that have also white LED. So it's RGBW cable. So it has a 5 conductors, and it's also very inexpensive. And here is connector where you plug 12 volts for your actuator. This potentiometer is going to be used for the speed of the motor. This is a safe button, so you're going to see this more details when we start testing. We have a manual control, so putting the with switch up and down, we actually would move slider up and down to tune the antenna manually. This blue and red switch, this is a presets. You would preset for a specific frequency, and then you will just press the button up and down on a higher lower frequency, and it will automatically move the slider to predefine the location, and then you would press that yellow button to set that location. This is a green button, it's exit button, so if you go in any of those and you just don't want to make any changes, you will just press the exit button and it will exit out. On this side there is cutouts for the programming the PIC chip. So instead of having a separate connector here, I just put on the board traces as an edge connector, and then you plug your programmer into that. Programmer that I'm using, it's PIC-2. There is also, I have several of those, there is also PIC-3. PIC-2 you cannot buy anymore because they don't make it, so you can maybe only find that somewhere, you know, used one. But the PIC-3 works the same. I only like a PIC-2 better than PIC-3, even I have the PIC-3, is because the PIC-2, it's automatically detect what a PIC microcontroller you are using. So it comes here, you know, with connectors. So for programming, that last pin number 6 is not used in a controller. So you can see I made an adapter cable that plug in the programmer, and on the other side I put the edge connector adapter. So when you're programming, you just plug it in. You don't have to use a PIC kit. There are lots of programmers for PIC microcontroller. This one is very, very inexpensive. I think it's about $20–30. I didn't buy them in a long time because at one point I bought 5 or 6 of them, and I also bought a couple of the PIC-3. So, but I'm still using PIC-2 because for programming there is no difference between those two. For programming the PIC microcontrollers, I'm using compiler. You can see here it's a PIC Basic Pro compiler. Current version of that controller, it's PBP3, and this is made by Microengineering Labs, and their website is emilabs.com, and they also have another website that's called pbp3.com, and this is where you can actually download the software. Free version of the software, it's only work with a few chips, few microcontrollers, and one of the microcontrollers that it's covered, it's a PIC16F690. This is 20-pin chips, and this is the chip that I'm now using in this board. This is a regular SSOP chip that is not so difficult to solder, but on a board that I'm gonna release, it's gonna use a through hole chip, so you're gonna just plug it in chip and solder it, you know, from the opposite side. So this is covered what software we are using. So next I'm gonna show you how the software and programmer application looks like. Okay, on a screen we have open compiler editor. So this is actually the software for this antenna tuner. It's all documented and notified what actually each part of the code is doing. So you can see there are comment lines everywhere, and this is a complete software that will be available. This is actually source code. Also, there will be just a hex file included, so if you don't want to program it, if you want to keep it just as is, you can just install the compiled version of the file to the chip. This part here, this is a programmer's application. Okay, so you select here which chip you are programming. You go to the file and select import, and then you import the file with the name that you actually save it here. Okay, like this, antenna tuner PIC 16 Rev 1.02. So this is also here because I was using it. So first thing, you will select what a PIC microcontroller you are using, and this is a PIC 16F690. And now when we import this file, it says hex file successfully imported, and you would connect your board, PC board, and you will select bright, and it will write. Okay, so this is hex code information here, and it is actually your program. Okay, so there is still lots of space in the memory. So this is all about software. If you wanted to use, the same controller that I'm using it, but if you are skilled in electronics, you can make your own controller, and if you are good with Arduino, you can make the controller using Arduino. Okay, so the controller box is completed. The software is not completely done, but it's operational, so only what is left is to check SWR, for each frequency, and set up a location for the slider for specific frequency. Right now we have on the bottom part the show the value from analog to digital converter. This is coming from this potentiometer that it give you actually a location of the slider. On the top we have a frequency that we are tuning on. This is not done, software is not done for this part. I need to bring this, install this on antenna and check SWR and see the values and program it in. So right now this is manual operation, and slider is moving. You can see on a analog to digital converter the values. Okay, this potentiometer is also working. This is changing the numbers from 1 to 9, from 0 to 9 and the period, and this will be used to set specific frequency if you want to have something that it's not exactly on a frequency that you would work on, so just for custom frequency that you would set up this. So the buttons for the preset, they are working, and you can see it's changing the frequency, and it's a wavelength of each frequency. It goes all the way to 50 megahertz. So you would select frequency that you want to work on it. You will press the button and it will activate the motor to move to this frequency. So I will go and install this actuator and put this next to my gear, and we're gonna record how well it's working. Okay, here is the afterthought of the electronics controller for the antenna tuner. Due to the length of the the cable from the tuner coil to location where the radio is, noise is induced in a signal from feedback position in potentiometer, so I had to put some additional filtering for the signals. So what we have here, this is just some additional small cable that I installed here because I couldn't put it on the board. There are two capacitors, 0.1 microfarad, and one is connected between the ground and the signal coming from the potentiometer, and second one was between a plus 5 volt and the signal. And this reduces noise from the line. Even it's not 100% stable, you're gonna see it. It's analog to digital converter. It's kind of fluctuating 2-3 digits, but this is good enough for this purpose. And also I found out that speed of the linear actuator, even it seems to be that it's very slow, it's fast, and it's a little bit difficult to position it with a switch. You just pass the value that you need. So right now I implement pulse width modulation for the motor and reduce speed of the motor to 78%. If this is not enough, then I'm gonna program so that this potentiometer change the duty cycle for pulse width modulation, so that you can actually adjust the speed when you are getting close to the value. You can reduce the speed and set a slider on a coil on a correct position. Okay, so here is a remote control coil, actually remotely actuated coil, that is mounted on an attic. Right above that mast it's an antenna, so it's very short tube. The coil is connected ground to the mast, and the other side is connected to the antenna. Just to clarify differences between this antenna tuner and Versa tuner. This antenna tuner, it's actually tuning the antenna, in this case high-end VS18, and it's actually make the antenna resonant on a specific frequency. Versa tuner, it's actually matching the antenna with your radio, and the whole function of that, it's so that radio see 50 ohm impedance of the antenna. Those two are two different things. You cannot replace one with another, because most likely you will be out of range with the Versa tuners to tune your radio, and get an impedance of the 50 ohm if the antenna is not properly tuned. So this unit, actually this antenna tuner, is actually adjusting loading coil on antenna to resonate on a specific frequency. Here is the test setup to test remote antenna tuner and operation and performance of it. To do this test, we have a MFJ Versa tuner. We have Mini 60 antenna analyzer. We have this controller box for controlling the tuner, and then we have a software where we can see the results. You can see that MJF Versa tuner, it's in a bypass mode. So here is the bypass, and it's set to coax 1. Okay. Here is the Mini 60S. This is same as a Mini 60, except only difference I think it's that use 5 volt for charging batteries instead of 12 volts. So right now it's USB, it's connected here, and it's actually charging the battery, and it's also communicate to the laptop. Where is the software for testing? Okay, so here is a controller that is already programmed. We can manually control a motor, or we can also use the presets. Okay, so this is presets for different frequencies, and show the frequency and the wavelength, and it's also show on this is what actually the ADC should be set for the minimum SWR. So for example, we select a frequency and we press to execute button, and you can see that motor is moving and it's going to this specific frequency. So we see small drifting in this number, and usually it doesn't exceed 3 digits, and the 3 digits correspond for about 200 of the thousands location of the slider on a coil. So this is pretty much okay. It doesn't affect the operation of that of the tuner. So this button is not programmed yet for changing duty cycle on pulse width modulation, but right now to do the test it's really not so important. It's more important when you want to manually move this up and down to fine tune, because moisture in the air, the temperature, it's kind of affecting the potentiometer that is on the attic, and there is a possibility that actually it drift away. Also grounding of the antenna also has that effect on a location of the potentiometer. So we're gonna test this. Okay, so 800 meter band has a pretty wide range, and this antenna cannot cover the whole band without tuning it. So we're gonna just run it as is, and then we'll see how we can make some changes. Okay, so we run analysis on 80 meters. So we can see that it's only that center part. Actually, it's low SWR. And then if we move this coil, up, so for example here, and run the test, then analyze that, now. Okay, so now you can see that this is a SWR curve, that red one, and it's actually low in a high range. And now I'm going to make the coil longer. Okay, and then we're gonna repeat the test. And probably this will change to this range. Okay, so you can see that range change. Only on a 80 meters band with this high gain antenna, you would need to fine tune it for the range. And now we're gonna see how this thing works on a 60 meter band. So we are now 80 meter, So we are 60 meter band. This is value that we're looking for. Okay, so motor is moving and slider is changing, position on the coil. Okay. So we're gonna change here 60 meter band and we do analysis, and you can see that on a 60 meter band we have covered the whole band with very low, and you can see here that it's SWR, it's 1.00. Okay, so we're changing now to 40 meters band, 7 megahertz. Okay, and we're gonna see the results. So we're changing here the band on 40 meters and run analysis. Okay. So here we can see, the values on this part. Okay. So we're gonna change now to the next on 30 meters band. Okay. So we're changing 30 meters band also here and running analysis. Okay, so you can see it's also very, very good. Okay. We are changing now to 20 meters band. Okay. Now we're changing also on a softer 20 meters and run analysis, and you see that it's perfect. Okay, all 1.00. Okay, so next band, 17 meters. Okay. Okay. Okay, so on a 70 meters we have pretty much 1.18 SWR. Okay. Next band, (15 meters). So 21 megahertz. Okay, running the analysis. Okay, it's also, oh, this is not good. Okay, so we're gonna have to retune it. Okay, so basically how we can tune it, we select single frequency, running in a loop, and so now we have here the value, and now we manually moving the coil Okay, so we have a one Okay, so this is what value that it's supposed to be here. Okay, so right now I don't have yet made that you can actually change it, you know, your preset, so I have to actually do it, reprogramming it, but the original set value was 810 and actually it's supposed to be 829, so I'm gonna change that. Okay, so we are going to next band. It's 12 meters. Okay, and this is pretty much the same, so let's see what results we're gonna get. Okay, we are selecting 12. Okay, and then we run analysis. Okay, so we have 1.4 SWR, so let's see if we can improve that value manually. Okay, so on a 12 meters 871. Okay, so let's just run it to see. Okay, so we see now it's actually red line, it's all the way down. Okay, so let's do the next band. Okay, so this is 27 megahertz. It's CB band. Okay, so next band it's 1127 megahertz, 11 meters, and okay, so let's see what we can get here. Okay. Okay, so 11 meter band, it's also all zeros. Okay, so let's try the 10 meter band. Okay, so it says the same value. Okay. Run analysis. Okay, so we have also all zeros. Okay, so the last thing I'm gonna show you with this is 50 megahertz 6-meter band. This antenna is not made to run on this frequency. Okay, so we're gonna move that, and we're going to try to see, you know, what okay, so you can see that this SWR is not that great, you know. Resistance is also not that great, but if you really need to use it, you probably can reduce that value and improve that output just using the MFJ VersaTuner, you know, just on this band. Okay, so the last thing we're gonna try also that this antenna is not made for, we're gonna try 160 meters. Okay, so this is 160 meters band. So we're gonna move the coil. This is the value that I found that give you some kind of results. So maybe it would be possible to at least listen on that band if you cannot transmit. But I will try to make longer coil and see if this kind of improve on 160 meter. Okay, so we are selecting 160 meters and we do the analysis. Okay, so we have something. Actually, it's much better than 6-meter band. Oh no, it's not better. Okay, so I thought this is the WR line, but this is not. So let's see if we can manually found some better location. Okay, so going down, it didn't help anything. So I think this is a WR 2.8. It's the best thing you can do, but I don't think that this is any good. Okay, so I think this is best what we can do. 2.87 on 160 meters. Okay, so next things we're gonna do is actually see how this thing's working with actually radio. Okay, so the test we're gonna do with all band radio Yaesu FT857D. In this part of the video we're gonna show how to tune the antenna with a radio. So we're gonna demonstrate this on a 7 megahertz. Right now we have a set up 7 megahertz on a tuner. Position of the slider on a coil should be on this number, and right now this is the position of the slider on a coil. We're gonna use VersaTuner 2 to see the results. Right now it's in a bypass mode, set for coax 1. This is where antenna is connected. So those buttons right now doesn't do anything because we are in a bypass mode, and we can look at the reflective signal on a meter. So when we are looking at right now, it's actually pretty high. So we're gonna try to manually move the slider until we get the best results. Okay, so this is the current location of the slider. So we're going to move it down. Okay, so we know approximately where it's supposed to be because this is already preset in the memory. So I knew right away that it needs to go down. So we have put it close to that value just to start with, and then we're gonna look the meter. So we see right away that signal, its reflective signal is very low. So you can even operate on that because right now value is somewhere 1.2. So we're gonna to move slightly up. Okay, so this is the value that actually doesn't move a needle for the reflective signal. Okay, so now we have the save button, and this is a save button. So we're gonna save this location in the memory, so next time when you come to 7 megahertz frequency, you can actually go right away to this value. So pressing the save button, it saved that location. Okay, so if we go to the different band, you know, this is for example 10 megahertz, and we go back, we see that this value it's saved. Okay, so basically now we're gonna put this to the tuner, you know, to tune it on a radio, and we see that the tuner is not set right. So basically what we do, we try to find the value, you know, for the inductor, you know, that it's the lowest value. Okay, so now we're tuning first antenna. Okay, and then we tune the radio, and it's on a 0. Okay, so we're gonna repeat this with other frequencies. We are on a 10 megahertz. This is preset location. This is where the slider is right now. So we're gonna press the set button and move to that location. Now we're going to look the output. Okay, so SWR is pretty high. So best thing we can do here, it's a 2 with this antenna. Okay, on a radio, you know, this meter here, it shows only a couple of dots, even it's 2. So now we're gonna fine tune it with the tuner. We're gonna put it in tuning mode. Okay, and first we're gonna adjust the inductor. Okay, so we have a best on I. We'll try to first adjust antenna. Okay, so antenna doesn't do much. So we are on a SWR 0. We're going to next frequency, and this is 14 megahertz. Okay. Preset value in the memory, it's 889. Current position is 576. So we press the set and we go to that location. Okay. We are putting tuner to bypass mode. Okay. So 14 megahertz, it's pretty good. It's somewhere around 1.2. So we are moving up and down. Okay, so we are on a new location. Okay, so we're gonna save location. Okay, now we're gonna turn tuner on. Okay, and I put in transmitter and antenna capacitors to middle position. Okay, so best SWR we have on a J location. So with first tuning antenna capacitor, and then we do okay. So okay, so needle is not moving. So this is how we tune on 14 megahertz. We are going to next frequency. (18 megahertz). We move the slider to this 18 megahertz. Okay, so now on a radio, okay, we need to move in a bypass mode to see the results. Okay, so SWR is pretty high, so we're manually moving. Okay. Okay, so this is the best location. We're gonna save it. Okay. So now we're gonna put it in a tuning mode. Okay. Both capacitors to middle position. Okay. So it's almost not moving. Okay, so this okay, so needle is not moving, and we have 18 megahertz on both positions. Okay, so let's do the next frequency, 21 megahertz. Okay, so we are just radio 21 megahertz. We're putting tuner in bypass mode and check that out. Okay, so it is extremely high. Oh, and 21 megahertz. We didn't press the set button to move to preset location. Okay. So SWR, it's somewhere around 1.5. Now we're gonna manually move the coil. Okay, so this was wrong direction. Okay, so this is best we can do, 1.5. Okay, so now we're gonna switch tuner to tune mode and see. Okay. Actually, let's see. Okay. So I is not good location, so okay, so this is best we can do. It's close to zero, but the needle is still moving a little bit. Next thing is we are going to next band, 24 megahertz, and we also do this on the radio. Okay, so on a 24, okay, that's good enough. So the values are very close, so we're gonna leave it like that and manually tune it. Okay, so WR it's close to the 2. Okay, so this is we are not in bypass mode. Okay, so in a bypass mode we are on a 0, so basically you don't even need to tune it, but we're gonna do it just to show that if your tuner it's in a tuning mode, you still have to have it correctly. Okay, so okay, so we are at that point that needle doesn't move at all. Okay, we are going to next band. Okay, this is 27 megahertz. Okay, so we're putting the radio on channel 20. Okay. We are putting in bypass mode. Okay. So first move it to preset. Okay, so it's in a preset mode. Okay, so SWR is somewhere between 1.1 1.2. I don't know if we can do any better than that, but we can try. Oh, okay, so it went down a little bit. Okay, so we're gonna press the save button. Okay, so we are here. So now let's put it in a tuning mode. Okay, so we are on a 20 megahertz, 27 megahertz, and it almost doesn't move. Okay, so we are selecting next band, 28 megahertz. Okay, and also changing on a radio, 28 megahertz, and we are putting tuner in a bypass mode. And to see SWR, and it's extremely high. So even this antenna is supposed to be 80 meter to 10 meters. It doesn't work very well on a 10 meter band by 28 megahertz. And I think it's my fault that when I assembled that I didn't measure it, so I think antenna is a little bit too long. And problem is you cannot make it shorter if you don't climb on a roof. Okay, so 28 megahertz doesn't work very well. So what we're gonna do, we just try to tune that with a tuner just to protect the radio. This is inductor on an L position. Let's try the K position. Okay. So needle doesn't move. Okay, so even we can protect the radio with minimum SWR, but antenna is not very well resonant on 28 megahertz, and I'm gonna be forced to go and climb on a roof and make the antenna shorter. This is addition what could be done. This radio has a serial output, and using the cat cable it would be possible to connect the radio to this tuner. So when you change the frequency on the radio, it will automatically change the frequency on this controller box, and it could be programmed that it's automatically tune that resonant coil. But I'm not gonna do it right now, because then this tuner will be specifically tuned for this radio and this antenna that I have. But it's possibility. I'm probably gonna do it for myself and maybe post a source code, and then you can maybe program it for your own radio and make it a fully automated tuner for the resonant coil and antenna. So basically with this, you can see that You can tune your high-end 18 VS remotely from place where you have your radio, that you don't have to go and change the jumpers on a coil to make it resonant on a specific frequency. So this will conclude this video. Thank you for watching.
Hey, thanks for watching. Hope you liked it. If you did, don't forget to like and subscribe. Also check out these other cool videos and check out our website. If you want to help support this channel, you can do so on our Patreon page. Links are in the description, and I'll see you in the next one.